Okay, exercise 1604, question 11. Love this question. We've got square root of x minus 5 over x plus 3, and we've got to make x the subject. Well, again, this is the type of one I would have to tease out a little bit to see where I'd go with it. But let's state the question again, and then I'll just play with it and see where it takes me. So I've got y is equal to square root of x minus 5 on x plus 3. Well, first of all, I need to remove the square root sign. It doesn't matter too much, what I do here. So I'm going to square both sides. I'm going to square this side. I'm going to square this side. So I'm now left with y squared is equal to x minus 5 on x plus 3. Fantastic. Now I need x, obviously, on its own. So first of all, when I see something like this, I want to get rid of the denominator. So I'm going to extend the vinculum. I'm going to multiply both sides by the denominator. Here we go. Now, having done that, I can now divide out x plus 3. Well, x plus 3 divided by x plus 3 is 1. And that's going to leave me with this thing here. So I'm going to expand this right now. So I've got x times y squared, so xy squared, plus 3y squared is equal to x minus 5. All right, that's looking good. So now we've got rid of the denominator, we've got rid of the square root sign, and I think I can get x's all onto one side now. So I want to get this x to the other side. I want to get the 3y off to the other side as well. So let's start with the 3y squared. So I'm going to take minus 3y squared. I'm going to subtract 3y squared from both sides. So crossing that out, I now have xy squared is equal to, and I've got x minus 5 minus 3y squared. Now, I do want the x on the other side, so I'm going to subtract x from both sides, leaving me now with xy squared minus x, and now I can see a way to factorize. And when I factorize it straight away, it gives me the opportunity to make x be on its own. So I'm going to put x outside the bracket. X is the only thing that is common to these two, and I can now ask the question, what times x makes xy squared? And the answer is y squared. What times x makes negative x is going to be negative 1. And of course, it equals what it was before. So now I can take the step and go, let's divide both sides by the thing here in brackets, which is y squared minus 1, y squared minus 1. This is looking good. So I'm now going to go divide this. So y squared minus 1 divided by y squared minus 1 is equal to 1. And I got 1 times x is x. And I'm left with negative 5 minus 3y squared and y squared minus 1. Well, we've got a negative out in the front there. I don't really want that. So I think if I was to multiply the top and the bottom here by minus 1, I'd end up with less components here. I think these, well, at least one of these would become positive in some way. Let's try that out now. So I'm going to multiply this by negative 1 and multiply all of this by negative 1. So let's see how that plays out. Notice I have to do the bottom and the top. Otherwise, I have to multiply both sides by negative 1. So I don't really want to do that. Well, negative 1 times negative 5 is going to be positive 5. I'll put 5 there. Negative 1 times negative 3y squared is going to be positive 3y squared. Fantastic. And already we've got rid of one of the components. Negative 1 times y squared, it makes that negative y squared. And negative 1 times negative 1 is plus 1. So now I can even make this more succinct by reversing these two fellows here. So let's do that now. And I also want the 3y squared up front. I want to express the coefficient and the variable first and leave the whole number second. So I'm going to say x is equal to, this is my final statement now, 3y squared plus 5 on, what have we got here? 1 minus y squared. And that's fairly succinct now. We've removed one of the components and we've got something which doesn't look like it's sitting out there as a negative. Okay, I think that's the answer.